How are you, everybody who is watching this video? Whether you're international or a national viewer, you're warmly welcome into this comfortable place, and I have a good news for you in this session. So my name is Olenjolain Moko TAYAI Lusingo. Simply just call me Olenjolai. I'm from beautiful countries that call Tanzania. This is our national flag. And if you are a Tanzanian, also you can wave your national flag to indicate that you have a true love to your country. So I really honor all our international and national viewers who are really connected or tuned in or reconnecting themselves into the online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. I have a good news for you in every sessions, and in every sessions I would like just to tell you that it's an event. So I don't want to waste much of your time. I would like just to spend a few minutes to give you a little introductions, and then we'll go into today's session. I would like to take this opportunity to welcome all our national and international viewers into our online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Simultaneously, I would like to welcome you into one of the YouTube channels that called Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAIM. Well, you have so many questions concerning about what you are hearing right now. That is good, and that's how the human nature, and that's how God has created us, because God has created us in image God has created us God has created us in His image and the likeness. So He gave us understanding and intelligence so that we use effectively once that we find something that which cause us to ask ourselves so many questions. So I'm very happy to have you, and one of the questions that you might be having in your mind, what are we doing? Why should you join into online undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM? Or where is the direction, where the destiny of online undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM? Or maybe some of our students or some of the viewers, you are asking yourself that what the vision that these online institutions have. So I would like to declare this is the vision that we have received from our Father who is in heaven, who have called us in this ministry of teaching. Well, we have an assignment to teach, incubate, train, mentor, lead, and even motivate and encourage some group of undergraduate students who will be ready to take the classroom instructions in fundamental and core courses and combine with the knowledge and wisdom from the Word of God that written in the Holy Bible in order to solve real-life problems. So, well, our vision has 4 parts. Number 1, we'll be teaching you to extract knowledge and wisdom from your formal educations in core and in our core courses, in our core and fundamental courses in engineering and science. The second part will be teaching you to extract knowledge and wisdom from the Word of God, and the third part will teach you how you can combine these two different knowledge, or these two knowledge actually in order to solve real life problems. We have different scales of real life problems. You are undergraduate students, so we're expecting to solve a problem which is proportional to your level of education, or to your capacity, or to your ability of thinking. So you're expecting you to solve possibly intermediate real life problems, or large real life problems, or extraordinary real life problems which actually is waiting for you, whether from your family or your community, or maybe from your village or from your country. So we'll be using the curriculums of United Republic of Tanzania, and especially that because this will be focusing in Tanzania. We have TCU and NACTE, that means the Tanzania Commission for Universities, and also we have NACTE, National Council for the Technical Education that make abbreviations of the NACTE. So we'll be using those two authorities or curriculums or syllabus from them, and use different institutions. So I would like just to tell you that you have been asking yourself so many questions that you find maybe engineering mathematics, it has been a critical problem to you. Maybe scientific mathematics, it has been critical problem for you. Maybe you are undergraduate students, and then you have been looking for a teacher who can teach you well about the beauty of engineering and scientific mathematics for the rest of your life. And then you have been roaming around. You have been loving mathematics, and then you decided to pursue engineering or science course. So you've been looking for the people who have the same mentality of loving the beauty or the queen of engineering, that is mathematics, and even also later on we'll be having some other special engineering programs and even science programs. So stay tuned. This is the right place for you. We are teaching, and even we are providing and just uploading so many videos of teaching, of training and teaching our students who are specifically right now, they are taking their bachelor degree or the first degree in any of the institutions in Tanzania, or any college in Tanzania, or any university in Tanzania, or in Africa, or worldwide. So you're only welcome. Make this as your home place. You will find so many contents that will make you to love engineering, higher engineering and scientific mathematics for the rest of your life. So please welcome, and let me just navigate you into few informations before we start today's session. We have so many departments in this online undergraduate Polytechnic Institute of Tanzania. One of the departments is called the High Engineering and Scientific Mathematics, where we are teaching you 12 courses or 12 modules. Four modules from Dar es Salaam Institute of Technology, and 4 courses from University of Dar es Salaam, and 4 courses from University of Dodoma. So total makes 12 subjects or 12 modules of higher engineering and scientific mathematics, which actually is going to cover all the material that you need to know as engineer or a scientist in any field that you are pursuing in any institutions or college or school of engineering, so school of whatever, or school, or any higher schools or higher educations, or we call this quarterly or tertiary education. So we have the modules we have today is called the calculus. This is taught at the DIT, Dar es Salaam Institute of Technology. And then we are in chapter 5 that called Fourier series. Ladies and gentlemen, say Fourier series. This is a very important topic, and actually it has been covered according to my research in so many institutions, in so many engineering colleges, in so many engineering universities and science universities. You have to cover and you have to know all about Fourier series, because there are so many applications in different fields of engineering and science. Then we have, I will mention subtopics that we have. We have almost 5 subtopics. Yes, 5 subtopics in this one of the longest chapter. And then this is lecture 1, which is general introductions of the Fourier series. At DIT, this module is being taught in the first semester of the first year. I don't know about your institutions or in your college. You can tell me in the comment section. Again, in case you want, if you feel from your heart you want to offer God your free willing thanksgiving through these programs or through online undergraduate Polytechnic Institute of Tanzania square bracket OLENJOLAIM, then you're warmly welcome. You can accomplish it through this telephone number 0759745331, and reals your free willing thanksgiving will be received with great honor and thanks, and to be used effectively to pay for the running cost, because we expect to have more than 500 lecture videos and tutorial videos of higher engineering and scientific mathematics, and we are going to upload them into our YouTube channel. So there is high running cost for one video to be published publicly. So you're warmly welcome, and realize that you are allowed to offer an amount that you know yourself that it will contribute and make this work to be in progress for the present and future generation. So let us go into the today's sessions. As I say that we have the general introductions of the Fourier series. We don't have any quick review. I would like just to remind you that the chapters or topics of calculus, because I mentioned this in the remember that if you want too much details about calculus, you have to go into the general introductions, into the lecture 00. Lecture 00 is still in this channel, general introductions of calculus. General introductions of what? Of calculus. So topics of calculus. So I have mentioned that we are going to cover according to the curriculum and syllabus of NATE, and the reference of the Dar es Salaam Institute of Technology, which is similar to even as an institution like Arusha Technical College, Karume International School, Karume Institute of Science and Technology, and even some other we call them institutions that will be focused on the competence based. We say that we are going to cover, I'm going to teach you 7 topics. The first one is called the theory of limit. Okay, the second topic I'm going to teach you about Laplace transform. Say Laplace transform. Okay, this is the promise that I gave you. The second topic is called the inverse of Laplace transform. Inverse of Laplace transform. Inverse of Laplace transform. And the first topic is called applications. Applications of Laplace transform. And then the fifth topic is Fourier series that I'm teaching you today. Fourier series. Fourier series. And then the sixth topic is called the complex Fourier series. Complex or exponential. Complex or exponential Fourier series. Exponential Fourier series. Okay? And then the last chapter is partial. I'm going to teach about partial derivative. Partial derivative. Partial derivatives. Partial derivatives. Partial derivatives. That's what I'm going to teach you. So these are so today we are going to take a look on Fourier series, right? So say Fourier series. So the fundamental question, let me just mention quickly 5 subtopics of, because this is the general introduction, subtopics of Fourier series. Remember that we have in engineering, we have Fourier series and also we have Fourier transform. So don't confuse. Fourier transform is something else and Fourier series is something else. So we'll be teaching you in the second semester or in the modules that we call the advanced calculus about the Fourier transform, and even in some other modules or some other courses of other universities. So stay tuned. Remember, one of our specific objectives is to make you love higher engineering and scientific mathematics. But another specific objective that we have to help you in order to pursue or to do well in your continuing assessment. But also, it will be preparing you in order to do well in your university exams or end of semester exams or qualifying exams in some of the institutions or colleges. So we are here to help you. We are here to equip you. We are here to share. Remember that I don't know everything about calculus. I just know small portions of calculus, but I'm ready to share with other present and future generations about what I know about calculus, right? That's my responsibility as a teacher, and it's a responsibility I've been given from my father, who have been teaching me the beauty of calculus for more than 10 years right now. So you see that for more than 10 years I've been learning the beauty of calculus. So, and also I expect to learn the beauty of calculus for the rest of my life. So we are going to cover basically 5 subtopics of Fourier series. The first subtopic which we have to cover, and we are going to begin to build a foundation today, but the devil will not be able to break it in, is Fourier series of periodic function. We'll teach about Fourier series of periodic function, okay, of periodic function of 40 of t is equal to 2 pi. We'll tell you what does it mean. Then we'll teach about Fourier series. Fourier. It depends. You can just pronounce Fourier. But Fourier, it is a name of mathematicians, right? Fourier series of 40 of none. So here we teach about periodic function, but here we are going to teach about Fourier series of non-periodic function, right? Fourier series of non-periodic function. Okay? So then we'll teach you about Fourier series of even and odd function. Ladies and gentlemen, we teach another subject that's called Fourier series of even and the odd function. Odd functions. Then the first topic we are going to teach you about Fourier, the first subtopic. These are, I call the syllabus categorize them as subtopics, but the way we are going to cover and how we have to cover in order for us to be competent, we are going to consider them as topic. So it means the topic of Fourier has 5 subtopics according to the syllabus, but frankly speaking, Fourier series has 5 topics, not subtopics. And I will show you, or you realize yourself and agree with my idea of having 5 topics rather than 5 subtopics. Fourier series of half range. Say Fourier series of half range. So stay tuned, half range. And then the 5th subtopic that I will be teaching you, I'll teach you how you can find Fourier series over any range. Fourier series over any range. So you have to be well energetic so that we'll be together in every subtopic or topic. And today we are going to start with the first subtopic. So stay tuned. Okay, so let us take a look of the first subtopic that's called the general. The today's session. Today's session is all about the general introduction of Fourier series. So say general introductions, we want first of all to understand the knowledge. So let us begin with the term first. This is the new vocabulary for the many undergraduate students, because we have never learned this concept during our advanced studies. So Fourier series, right? So others, as I say, that even yourself can pronounce Fourier, somebody can pronounce. But I think that the proper name is Fourier series. That's the kind of the French name. So that's why it's better to be careful in the pronunciation. So the fundamental question, which will be the first question, because we don't want to waste much of your time, what is Fourier series? That's the question we have on the spot. What is Fourier series? Ask your neighbor, pause the video, and ask your neighbor, and then try to answer it within a short time. What is Fourier series? Well, there are so many definitions or so many sources that have defined the terms Fourier series, but I preferred one of them, and I would like to share with you one of the definitions that I found in different reference books and different resources, as I've mentioned in the lecture 00, the general introductions of the calculus, because I mentioned also the reference books that you need to go through in order to understand this concept, okay? So Fourier series simply say that this is a periodic, so we say that Fourier series is a periodic. This is a periodic function. It's a periodic function composed of harmonical. You'll understand later the meaning of this word harmonical. Harmonical related sinusoidal. Related sinusoidals combined by weighted sum. Sinusoidals combined by the weighted summation. This is one of the sources that define Fourier series, a periodic function composed of harmonically related sinusoids. So sinusoids combined by the weighted summation. So when you say about Fourier series, one, you should have something in your mind that we are going to have a number of terms, okay, because it depends on the extension of the series. So even in Fourier series, just like with for those who we have taught them Taylor series, Maclaurin series, binomial series, during your second year we talked about binomial series or binomial expansion. So it's just a series, or just because we began to teach you the concept of sequence and series at the first chapter of the form series. So we introduced you about the nature of the series. So the same concept is going to be used in that in case of the series, we'll be using either addition or subtraction in order to just have an operation between the two terms. Right? So that's what you have to expect. However, that here we are going to focus mainly on the periodic function. That's why the Fourier series, first of all, it's a periodic function composed of harmonically related sinusoidal combined by the weighted summations. So first of all, because what does this mean, that the periodic function? Well, here we are going to learn about Fourier series of non-periodic function. Any non-periodic function, we have to convert it, or we have to change it to become periodic functions in order to use the concepts of Fourier for concept of Fourier to find its Fourier series, right? And the meanings. That's why we say that any Fourier series is periodic function, because even the one that which is not periodic functions, we are going to extend its the graph and repeat it several times until we have a periodic function first, and then now we can find the Fourier series, right? So that is one of the definitions of the Fourier series. But I think that I'm kind of passionate to give you the second definition of Fourier series, because actually this is a very important concept in undergraduate level. So some references also define Fourier series is an infinite. So I say that Fourier series. Possibly I pronounce this term wrongly. It is an infinite, but that should not be the challenge to you. Is an infinite series. It's not infinite. An infinite series of trigonometrical functions, of trigonometric functions geometric function which represents an expansion which represents an expansion or approximation So Fourier series is an infinite series of trigonometric function which represent an expansion or approximation of a periodic function Wonderful. So this is the second definition of Fourier series. Ladies and gentlemen, I would like to build the strong foundations of Fourier series in your mind, and you have to stay connected for the next topics because this is very interesting. It's an infinite Fourier series, an infinite series of trigonometrical function which represents an expansion or approximation of a periodic function used in Fourier analysis. A periodic function. That is. So Fourier series, first of all, is an infinite series of what trigonometric function, which represent what an expansions or approximations of a periodic function. That's all. That's all. So while in first definition, say first of all, Fourier series is a periodic function composed of a harmonically related sinusoids combined by the weighted summation. While the second definition, Fourier series is an infinite series, first of all, you have to expect that, remember that Fourier series is what it, this is an infinite. First of all, it is an infinite because you have two types of series, finite and infinite. It's an infinite series of 40 against this is trigonometrical. So it will involve trigonometrical functions. So in say trigonometrical functions, which means about cosine and sine. Trigonometrical functions which represent an expansion or approximations of 40 approximation. So this is an expansion or approximation, right? And also this one, it also should be periodic function. So these trigonometrical functions, sometimes in some of the, we just call this sinusoidal what? So we call sinusoidal functions, right? So that the meanings of 40 of Fourier series. So before I go into too much details, I would like just before I teach about what the meanings of periodic function, because you had this for vocabulary, I would like just to spend a few minutes on describing to you some applications of Fourier series. Why are we learning Fourier series? That's a very important question. Why are we learning Fourier series? Where do we use Fourier series? Fourier series is one of the applicable field of mathematics in engineering and also science, and even in the normal real life. For example, in electrical system or electronic system, telecommunication system, we have some of the electrical components or electronics components, which we call them Fourier components. So ladies and gentlemen, let me present within a few minutes about applications of Fourier series. Why do we learn Fourier? Why do we learn Fourier series? Right? Why do we learn Fourier series? So we have so many areas of applications. Firstly, we use Fourier series in electrical engineering, especially in control system, in electrical control system. Also use we use the concept of Fourier series in vibration engineering, vibration analysis, which is civil and mechanical. Analysis. Here we have a field of civil and mechanical engineering. Then also we use this one just for acoustics. And this acoustic, we call it sound engineer or electronics. So use Fourier analysis, Fourier series in electronics, and especially in acoustic, which means sound. The first area of applications we apply Fourier series are in engineering in the field of optics. Optics means light. Optics, so this is all about mechanical plus science. So use Fourier series in optics. In case that you are learning about optics or your field is all about optics, expect you to find some of the formulas which involve Fourier series, right? Also, Fourier series is used in telecommunications or in electronics. It's used in signal processing. Signal processing. Signal processing. Say signal processing. So signal processing. So it is used Fourier series is used in signal processing. So this is all about electronics. Electronics plus what? Telecommunications. Electronics engineering. Electronics engineering plus also telecommunication engineering. Also, we use concepts of Fourier series in image processing. Image processing. So image processing means that we find it in electronics, in computer, in telecommunication, etc. Field. Those are the fields that you can learn about that concept of image processing. But also we can find the use of Fourier series in quantum computers or in quantum mechanics. So quantum mechanics, we can use Fourier. This is specifically for the quantum computers. Another field that we can apply these concepts of Fourier series is econometrics. Econometrics. Then another field that we can apply this one is the resolutions of partial differential equations which appear in the many mechanical engineering problems such as heat diffusions, wave propagation. So this is, yes, solving what? Solving of partial differential equation. Example, heat diffusion. So this is all about mechanical heat diffusion. Also we have wave propagation. We need Fourier series also to learn this phenomenon. The 10th phenomena is called the discrete time Fourier transform. Discrete time Fourier transform. So those are some of the applications of Fourier series in the field of engineering and science. So enjoy it, okay? And then you have to understand that this is the one of very important subject for you to master. Okay, I'll let you see. You can take a pen after listing those. So if you learn about image processing, expect to meet with Fourier series because you cannot finish the subject of image processing without touching Fourier series in image processing. But we have some really life examples of periodic key functions, okay? This is all about something else. So before we define the meanings of the term periodic key function, let me just give you a brief introduction about the Fourier series. The Fourier series provides us of Fourier series. We say that is the method that provides. So this is the method that provides the technique of analyzing analyzing periodic key function, technique of analyzing periodic key functions into periodic function into the constituent components. Constituent components. So say Fourier series is the method that provides the technique of analyzing periodic function into their constituent sorting components. Okay? So that is a very important piece of information. So we'll be analyzing, we'll be given a function, and then once we find its Fourier series, we can find its, we call it in constituent components as the terms. So it means that, for example, if you've been given that maybe express, let's say, sine of x, let's say, and then we find that we have the first term plus the second term plus the third term. So first term, second term, third terms, this was called the constituent components of Fourier series. Practical examples of Fourier series are practical examples. For example, alternating current that you are using domestically or in industries. Alternating current, in short, you call it AC current. So the alternating current, it's a practical example of Fourier series. Why? Because it can be either sinusoidal or sinusoidal function. So that's one of the practical examples. So when we see how the alternating current is actually creating the crest and trough at the wave signal, then you find that we have different constituents of Fourier series. So that's the first practical example. The second practical example of Fourier series is voltage, alternating voltage, because that is alternating current. So another example is alternating voltage, which you call AV. So the example velocity also can be described as one of the practical examples of Fourier series. Also, we have displacement, because these are vector quantity displacement. Not all the vector quantity, but these are some of them. Then you have acceleration of slider crank, acceleration of slider crank mechanism and acoustic waves. And also another practical example is acoustic waves, sound waves, by the means of acoustic waves. So these are the practical examples of Fourier series. So ladies and gentlemen, after giving you the overview of Fourier series, then now allow me to take you into a very interesting point, which I believe that you've been waiting for it, okay, for some time. And this point is all about periodic function. We are learning the subtopic that called the Fourier series of periodic function of t is equal to 2 times 5. What does it mean? So then, ladies and gentlemen, of undergraduate level, let me now introduce to you the new function which is called the periodic function, which also is the heart of Fourier series, because we say that Fourier series itself is a periodic function, right? It's periodic function. So if it's a periodic function, this periodic function is the heart of what? Of Fourier series. So we have a fundamental question, which is question 2. What is periodic function? What is periodic function? What is periodic function? That's the question. Having this periodic function, then you have to define, you have to mention some examples, right? So there are so many definitions you can find in different resources about periodic function, but I prefer this one. Periodic function is any function that obeys what? This condition. That obey condition of periodicity, that is T or f of x is equal to T of x plus 2 pi. Condition is f of x is equal to f of x plus t. F of x is equal to f of x plus period t, where for all values of x, where t stands for period. So a periodic function is any function. Is any function. It can be any function. Any mathematical function that obey the conditions of periodicity. And this is the condition of periodicity. So f of x is equal to f of x plus t, where for all values of x, where t is what? It's period. So before I give you an example, also I'd like to define a non-periodic function. A non-periodic function is any function that disobeys the condition of periodicity. Mean that to say f of x is not equal to f of x plus t. Okay. So this is the case. We say that a non-periodic function is any function that disobeys there. So this one disobeys what? The conditions of periodicity. Now that f of x is not equal to f of x plus t. So we are t is what? Period. So that's the names of periodic conditions of periodicity. So example of periodic function, example periodic function is sine. So let us prove that sine is a periodic function. So to prove that sine of x is a periodic function, first of all, we say that we have to recall our condition. F of x should be equal to f of x plus t. So the period, so we say that this period t always is equal to, for what's period? Period, it's a time taken by the body to complete one cycle, right? So period, simply, this is equivalent to 360 degrees. But this is equivalent to 2 pi. Why? Because you know pi radians is equal to 180 degrees. So for the periodic function, any periodic function repeats after 2 pi. For periodic function, so that t is equal to 2 pi. So right now we have to prove that. So you have to show that if sine is a periodic function, you have to say that f of x is equal to f of x plus 2 pi. So instead of f now, we are going to replace f with sine. So let us show that the right hand side is equal to the left hand side. So sine of x plus what? 2 pi. So suppose that this is equation 1. So you need to show that the left hand side is equal to right hand side. So to show, you have to consider the right hand side. You have to understand double periodic function first at the foundation of Fourier series. If you don't understand the meanings of periodic function, then it will be a challenge for you to go through with Fourier series. So then we say that second step, so let's say that this is the first step. Second step, we far more techniques or some techniques that we taught in training. So I say consider writing hand side of equation 1. So consider right hand side of equation 1, we have sine of x plus 2 pi. Again, you have to recall the sine of a plus b. This is equal to sine of a cos of b plus or minus plus sine of b cos of a. So if that's the case, now we have sine of x plus 2 pi. Just to substitute. Suppose that this x is equivalent to a and then b equivalent to 2 pi. So this will be sine of a. What is a? Sine of x. Times what? Cos. Cos of what of b? What is b? It is 2 pi. Plus what? Plus sine of 2 pi. Then you have what? Cos of x. So sine of x plus 2 pi. This is equal to what? This is equal to sine of x cosine of 2 pi plus sine of 2 pi and then cosine of x. So but from the special angle. Okay, so it means that if this fact is true that cosine of 2 pi is 1 and sine, because remember that this is equal to cosine of 2 pi, sine of 2 pi is equal to 0. So if you substitute these two values in equation 2 here, okay, so in equation 2, then we find that sine of x plus twice pi. This is equal to what? Is equal to sine of x, and then times what? Cosine of pi, which is 1, plus what? Sine of 2 pi, which is 0 times cos of this one, so it means plus 0. So therefore, we have shown that because our objective was to show that sine is a periodic function. So sine is a periodic function because sine of x is equal to sine of x plus 2 pi. So hence shown or proved. But again, we have another interesting examples, because remember that as we said, or as we defined it, Fourier series is actually an infinite series of 40 trigonometrical functions. So we're expecting to have in our series the cosine or the sine function. So we have to expect, that's why that we're teaching you first of all how these functions are periodical. But again, we can maybe, for example, that we can have a graphical representation, right? So a graphical representation, suppose that this is y-axis, okay, y-axis. So you can show on the positive axis, and this is theta axis, okay? So it means that here you can have a dotted line, so you can have sinusoidal, depends, because for the sinusoidal, it means that when sine of 0, and then so you have sine of 90, we have sine of 180. So you see that the function repeat after a certain interval. So here it is pi, here it is twice pi. So you see that the complete cycle, here you have 3 pi, here you have 4 pi, here you have 5 pi, here you have 6 pi, here you have 7 pi, etc., etc. So it means that from this point to this point, we have a complete cycle, which is a cresty, combination of a cresty and trough in the language of wave, right? Because also we have introduced about wave during your ordinary secondary education. So this is the sine, okay? So this is the graph of 40. So this is the graph. So we say that possibly that we say this is figure 121. So it's called the graph of sine function. Okay, but again we have a second example of a periodic function. So example 2, it is what? Cosine function. So if a cosine function is a periodic function, then it has to obey what? The conditions of what? Periodicity. You remember that I told you the condition of periodicity. So it means that show that cosine function FCT obeys what? Obeys the condition of periodicity. The conditions of periodicity, right? So show that the cosine functions obey the conditions of periodicity. What the condition of periodicity, we say that is f of x. This is equal to f of x plus t. And because this periodic of 2 pi, so this also is equal to f of x plus twice pi. So that the conditions of periodicity. But this is in case the variable is x. In case the variable is theta, so we say f of theta is equal to f of theta plus t, and this also is equal to f of theta plus 40 twice pi. So that the conditions of 40 of periodicity. So this is the first state. You have to recall always the conditions of 40 of periodicity. So you have to check if cosines obey this. Okay, so you can start with what? Cos of x. Is it equal? So this is the question mark. It is equal to what? Okay, so in example 2, we have a responsibility as engineers to show and to realize and prove that the cosine function is a periodic function, because we are going to see it. Why am I teaching you about proof and use of conditions of periodicity? Remember that we said, and I say that Fourier series is a infinite series of 40 trigonometrical functions. So because it's a finite series of trigonometrical functions, and the two trigonometrical functions that we are going to use them oftenly are the cosine functions and the sine functions. So in the first example, I have taught you and I showed you how do we say, or how do we confirm and even realize that the sine functions is a periodic function, right? So right now, I would like just to take you that the cosine functions also it's a periodic function. So that's why we have a kind of the simple question. This is the kinds of the simple questions show that cosine functions obey the condition of periodicity, or show that cosine function is a periodic function. That is. So the first step, we have to recall the condition of periodicity, which I told you from the beginning. It means that a few minutes ago that f of x is equal to f of x plus t, where t stands for periods, and this condition should be valid for all the values, or should be valid for all the values of x. Also, t in most cases it is 2 pi, because we are dealing with one cycle, and one cycle has a total degree of 360. So that's why that we refer as 2 pi. However, that when I will be teaching about the issue of, or the concept of the half range, you might adjust this concept a little bit. And then this is in case that our variable is x. What if our variable is theta? What if our variable is time? Because somebody can have cos of t, or somebody can have maybe cos of theta, right? Don't worry about that. You just have to replace x with a new variable. So for instance, that if you are looking, we want to show that a certain function which its independent variable is theta, whether it is, we have to check whether it is periodic functions or non-periodic functions. So if you say that f of theta, this is equal to f of theta plus t, and this is equal to f of theta plus 2 pi, right? So theta, remember t stands for the 2 pi. So then we want to show that cos of x is equal to cos of x plus 2 pi. So that's the question mark, okay? So the second step, we have to consider the right-hand side of this equation. We have to show that we have to simplify, okay, we have to simplify this right-hand side function to be equal to the left-hand side function. And that the second step, ladies and gentlemen of undergraduate engineers, that I'm going right now, and you have to enjoy the beauty of Fourier series for the rest of your life, right? Tell me in the comment sections if you understand what am I teaching you. This is still a fundamental lecture. We'll go to the lecture 2. When we get into lecture 5 or 6 or 7, then you find things now get a little bit challenging. But I believe that you're going to overcome them because you love so much engineering, so that this stuff gonna be very simple for you and get prepared to enjoy the beauty of mathematics. So in order to expand this function, then we have to recall this is the steady state. Let us recall compound angle. Recall compound angle formula. Compound angle formula. Okay, compound angle formula of cosine. So in trigonometrical, we told you that cos of A plus B, this is equal to cos of A, this is times cos of B, then you have minus what? Sine of A, then times what? Sine of B. So these are the angles that you have. So if that's the case, we say that let A to be equal to x, let B is equal to twice pi. So if that's the case, now we say that our functions cos of x plus 2 pi, this is equal to what? So this is equal to cosine of 14, cosine of x, then times what is sine of 2 pi, and now cosine of x times cosine of 2 pi, minus what? Ladies and gentlemen, minus sine of 2 pi times sine of x, or sine of x times sine of 2 pi. So, but remember, I have said that cosine of 2 pi, this is equal to cosine of 360 is equal to 1, and sine of 2 pi, this is equal to 0. So ladies and gentlemen, now we find that in cos of x plus 2 pi, if you substitute, this is equal to what? Cos of x, or 1 times cosine of x, and then plus what? Minus what? So minus 0 times what? Sine of x. So it means this makes what? Cosine of x plus 2 pi is equal to the functions of left hand side in equation 1, which this one is what? Cos of x. So hence shown that cos of x is what? Periodic function. Obey the condition of periodicity. So remember that in Fourier series, we are going to deal with basically three main concepts, right? You know, the first concept is sketching. We'll be sketching these functions first. And the second concept that we are going to deal with is finding Fourier coefficient that I will teach in lecture 2. So you have to stay tuned because I would like to invite you in lecture 2. And then the third concept that we are going to find the Fourier series itself. Wonderful. So sketching, find the Fourier coefficient, find the Fourier series of all the 5 subtopics that I've mentioned before, or that's myself, I call them 5 topics of Fourier series. So wonderful. So it means that I have to teach and I have to start training your mindset to know the nature and the sketching that we are going to do, because these Fourier functions, when we want to deal with is, it will be bounded. We'll be focusing with one cycle right now in this first subtopic. Later on, you can focus with them even with the half cycle. That's a means of half range, right? So this half cycle, because it repeats itself. For example, the graph of the sine function, right? Of the sine function. So you see that this is the point that where we have an edge of the cycle. So this is the cycle from this point O to point B. So it means that from point B to point C is just a repetition of what we had there, of the same magnitude, the same angle. Then from point C to D, it's just another complete cycle, etc. To the point E. So it means that you find that OB, for instance, this one, OB is equal to BC. And this also is equal to what? CD. And this is equal to DE. It's still a same cycle. So you're dealing with what? You are dealing with only one cycle. So it means that you'll find that that's what we find that in many problems that we are going to solve, we bound that just we are dealing with one cycle, because we know that it's a periodic function, so it has a tendency or behavior of repeating itself after a particular interval. So for this function that we are learning in this concept, they repeat themselves after an interval of 360 degrees. Thus we call it 2 pi radians as engineers or as mathematicians in engineering field. Wow. So right now, after convincing you that the cosine function, convincing you mathematically that the cosine function is a periodic function, ladies and gentlemen, let me sketch its graph so you might have in your mind. It doesn't mean that we'll be dealing with trig functions only, trigonometrical functions. We can deal with polynomial function, and later on we can deal with exponential functions. But remember that this polynomial function, you find that we'll be converting them, and we have a series of trigonometrical functions. Wonderful. Infinite series also, remember that. So we said that the graph of sine, so of cosine. So remember, I'm building the foundations. Okay, so I want you to see the graph of cosine from positive side of x-axis and negative side of x-axis. Okay? Negative side of x-axis. Okay? So you have this. So suppose that we have also a dotted line, which we call the amplitude of our sinusoidal, and you can measure this amplitude. So it's 1, 2, 3, 4, 5, 6, almost 6.5. So 1, 2, 3, 4, 5, 6 here. It's just, this is sketching. Graph of cosine function. Okay, so mean that sketch the graph of f of x is equal to cos of x. So this is y-axis and this is x-axis. Wonderful. So this is cosine right now. Okay. So then we say that okay. So you can also have some angles here. Three, 1. Prime tool. One, two, 1, 2, 1, 2, 2, 1, 2, and 1, 2, 1, 2, 1, 2. I want you to get the big picture of the Radicki function. So this is, suppose this is pi, twice pi, 3 pi, 4 pi, 5 pi, 6 pi. This is negative pi, this is negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, negative 6 pi. And this is 1 maximum value, and here you have negative 1. Okay, so you know that cosine of 0 it's 1. So this is, so cosine of 0 it's 1, cosine of pi it's 0. So remember that this is a sketch. And then here we have again another cycle, and here again we have another cycle. So this is on the positive side, negative side. Also we do have so okay, so you see that now this is figure 1.2. So the graph of cos of x. So you see how periodic it is. So for instance, if you want to deal with this, we just say that depends. We can take from the negative side, can take its half cycle. So this is the half cycle. So this is the half cycle. And also you can take on the positive side the half cycle. So it means that this distance between here is what we call the period, which is called the 2 pi. But we can deal with the positive side itself. Okay, so we can deal with 1 half cycle on the positive side. So when we deal with this one cycle of the positive side, then this will be our cycle. So this is 90 degree, 180, 90 makes 14 2 pi. Wonderful. So this is figure 1.2, the graph of 14 cosine function. So you find that even the graphical, you can either show or you can prove that the cosine function or sine function is periodic function by using the conditional periodicity or by using the graph, because the graph itself here illustrate that these functions or these functions has a tendency of repetitions after a particular interval. So for instance here is from what in negative 2 pi to 2 pi, right? So negative 2 pi to 2 pi, or from 0 to 3 pi. So from 0 to 3 pi, or from 0 to 4 pi. So from 0 to 4 pi, you find that these functions has a tendency of repeating itself, right? Of repeating itself. So it means that after an interval again from 4 pi to 8 pi, you find also the functions repeat itself, right? So that's the concept that I wanted to share with you. So the graph of cosine is not equal to the graph of sine. There's a difference there, because sine of 0 is 1. No, cosine of 0 is 1. Sine of 0 is 0. So the graph, if for example want to sketch the graph of sine, then you'll find that this is the notations, right? So this is the, okay, this is the sketch. Okay, so similarly, if I want to sketch also the graph of sine here, this is the sketch. But just for the purpose of of understanding, as I drew in figure 1.2. Wonderful. Do you enjoy it? Tell me in the comment sections if you do enjoy this stuff. So then we say that, okay, so before I give you the homework and I end this lecture 1, I would like just to do the same example. So let's say that for this case, we say that we have tan. Okay, we have cos, so that's it. Okay, you can try those examples. But let me just eliminate this. Make that hyperbolic, you know that you don't want to, you are engineer, so we don't want to disturb you too much. So example 3, we say that show that cot of theta or cot of x is, okay, is a periodic function. It's a periodic function. Okay, so that is in case of the 3D function, right? But let me, because my aim, I want to show you a non-periodic function, right? So even here, Roman 4, show that if this, or show that the following functions are periodic or non-periodic function. So I say that y is equal to x squared. Okay, y is equal to 3x squared. Okay, periodic function. So show that y is equal to x is a non-periodic function, right? So solution. The first step always recall the condition of periodicity. So to recall the condition of periodicity, say that f of x, this is equal to f of x plus twice pi. Wonderful. So we want to show that f of x, which is equal to x, this is not equal to x plus twice pi. That's the meaning. And it's true. X is not equal to x plus 2 pi. Because there's an increment there. So hence shown. And no way out that you can simplify x plus 2 pi until you get x. So hence shown that y is equal to x is non-periodic function. We'll be dealing, as I said, that we'll be dealing with sorting exponential function, trigonometrical function, polynomial function. So in the previous two examples, I told you how you can show that a function is periodic function. In this second example, I was targeting to teach you how can we show that a particular function is non-periodic, because we say that according to Fourier, we have periodic and non-periodic. But remember that it doesn't mean that because y is equal to x or f of x is equal to x is non-periodic function, we cannot find its Fourier series. Later in the second subtopic, which is second chapter, I will teach about Fourier series of non-periodic function. So we can convey it because we can change. It depends. For instance, that we can define that, yes, we can condition these functions that y is equal to x under the condition that 0 degree is less than, or 0 is less than x less than or equal to 2 pi. So if we condition this one, and then we extend the range, the given range, outside of the given range on the left-hand side and outside the given range on the right-hand side, then we find that we can make a non-periodic function y is equal to x to be a periodic function. So you have to stay tuned. I'm not teaching you yet about how we can convert a non-periodic function into a periodic function. What am I teaching right now? How you can make decisions, or how we can know as engineering mathematicians that this function is periodic or non-periodic, because you should know it. That's the fundamental of Fourier series, right? So ladies and gentlemen, before I end this lecture 1 of general introductions of Fourier series, I would like to leave the homework 1. That's this, and this is example 1, because those are just like a fundamental examples. I don't count them as other examples, right? So example 1 show that the following functions are, so this will be example 4. Okay, good. This is example 4. Wonderful. Show that the following functions are periodic or non-periodic functions. So we have tan of theta, cosec of theta, sec of theta, and y is equal to 3x squared. So please make sure that you do this homework yourself. It means that effectively and excellently. And then once you are done, please submit your solution on the comment sections. However, that I know it will be a little bit difficult for you to write this in the comment section, but let me know just in the comment section that the homework I managed to, just tell me in the comment section I managed to solve the homework. And then because everything is simple, you just have to recall the condition of periodicity, and then you plug the given function and use them. For instance, for these 2, 3 functions, first function Roman 1, 2, 3, you'll be using proper geometrical identities or some properties of 3D functions in order to simplify and show that that particular functions obey the condition of periodicity. So this is the end of lecture 1. I thank God who have created me in his own image and likeness. I thank God who have given me and built this gift of teaching in me, as thou he has built the gift of swimming in the fishes. Similarly to me, that the gift of teaching God has built in me. I am a teaching, and teaching is me. So I really thank you also for, and I give God thanks for your time, that because you have decided to tune in online undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. The end of lecture 1 of Fourier series, it's the beginning of preparation for the lecture 2 of Fourier series, when now I'll be begins to teach you about, because in lecture 2 I'll teach about Fourier coefficients, and also I'll teach about Fourier series, and we are going to find the Fourier series as a primary or fundamental example, which will be example 5. So stay tuned, make sure that you do the homework. Remember to subscribe, then click the bell, then choose options of all, so you'll be the first student to have notifications once we upload any new video. Because believe me that in this year we'll be having so many contents for undergraduate higher engineering and higher engineering and scientific mathematics. So every day at least we'll add one video. So make sure to subscribe, and we expect to have more than 500 videos in online undergraduate polytechnic University of Tanzania. So remember to subscribe, and you have to make sure that you organize your timetable day and night at any times and anywhere to go through all of these contents so that you may enjoy the beauty of engineering. So my name is Olenjolain, well, from beautiful country, Tanzania. I love you so much, and I would like to invite you in the next session. Share these contents with other undergraduate students around the world, because there's no limitations of you to access these contents. You can access right now, and even future generations also gonna access and enjoy and find the simplicity of the learning process of engineering and scientific mathematics, because we want to encourage engineers and scientists in the country and even worldwide to enjoy the process of learning and reduce so much of the hassling. So may God bless you. I'm always praying for all my online undergraduate students. I ask you also to pray for me, and I would like to invite you into the next session. And may God keep you safe until that we meet in the next session. Stay enjoying the beauty of higher engineering, mathematics, and the scientific mathematics. May God bless you abundantly.